This question was given in one of AP calculus tests. The graph of y equals x squared minus 9 over 3x minus 9 has, okay, they didn't give you the graph, but they give you the equation. Okay, the vertical asymptote at x equals 3, a horizontal asymptote at y equals 1/3, and until now we are blind. We don't know how it looks like, but you could know. If you have a rational function, sometimes you could simplify first before you do the graph here. So as you see, x squared minus 9 and 3x minus 9, they have something common. So it will be x minus 9. You could factor it as x minus 3 times x plus 3. And 3x minus 9, you could take 3 outside. It will be 3 times, you divide 3x by 3 equals x. Negative 9 divided by 3 is negative 3. And now we could cancel x minus 3 and x minus 3. So the final evaluation for this function, the function will be x plus 3 over 3. So if you look at this, some of you said, oh, it will be quadratic. No, it will be rational. No, it will be linear. Looks like linear. It's 1/3. Like if you divide x by 3, it will be 1/3 x. The slope is 1/3 plus 3 over 3 is 1. If we graph this function, we need to look at the function and know it, how it looks like. So if you graph the function will start at b-intercept. You remember the formula, y equals mx plus b. B is the y-intercept. And we apply the slope 1/3, 1 up and 3 units to the right. 1 up and 3 units to the right. And then you connect that, make straight line. This is the function looks like, but we're gonna have gap on here. What is the gap? Which is the 0 of denominator. The 0 of denominator, which is you take the denominator 3x minus 9 equal to 0. We'll talk about 3x minus 9 equal to 0. And then 3x equals, add 9. And then you divide by 3x equals 3. So when x equals 3, 1, 2, 3, you're going to go up over here. And this is horizontal, a vertical asymptote. Vertical asymptote. This point doesn't exist. You need to make it tiny. This point here doesn't exist. Let me connect it a little bit more here. Let's try to make it manually over here. We have gap over here when x is 3. Gap. So the graph of this function, it will be linear, because if you simplify it, x minus 3 cancel x minus 3 as I told you. Then we graph it, it will be linear, but we're going to have to mention the gap on this line. We have a gap over here. X equals 3 doesn't exist. Okay, so we have to make like a punch over here or open circle. This is the function looks like. Now let's look at all options we have. So choice A, a vertical asymptote at x equals 3. Yes. How to find the vertical asymptote? Vertical asymptote, please listen to me and mark it down. Take, when you have rational function, take the denominator 3x minus 9, take the denominator, equal it to 0, then solve it for x. Finally, x will be 3. This is the vertical asymptote. the vertical asymptote, x equal 3. And x doesn't exist when x equal 3, the function doesn't exist. Now, horizontal asymptote, how to find the horizontal asymptote of rational function? Try to mark it down in your notes to find horizontal asymptotes. Here, let's do that. So this one is correct. We're gonna take the limit of the function when x approaches infinity. That's the horizontal asymptote. Horizontal asymptote is y equals something. What this something? It's the limit of the function when x approaches infinity, when x goes to infinity. So you could apply rules for that, and you could decide that even if you simplify the function, if you have the maximum exponent at the top over here, if the maximum exponent at the top, you have your x exponent 2 and you have x exponent 1. If the maximum exponent at the top, that means it will be infinity. The limit equals infinity. But if it's in the bottom, we're going to review that in different questions after that. If the maximum exponent in the bottom, then it will be 0. If we have same exponent level, like x squared and here's x squared, we have to divide coefficient. We will talk about that more next time. So horizontal asymptote is y equals 1/3. No, we don't see y equals 1/3. It will be infinity. Okay, removable discontinuity at x equal 3. No, we don't have another value over here. So if we have another value like step function and they give us another value here and they tell you that the function at x equal 3 is 5, let's say, we could say that. So this is no, we don't have that. And here is an infinity discontinuity at x equal 3. An infinity discontinuity, no. It's discontinuous at x equal 3 only. Okay. But this expression, an infinity discontinuity, is not applicable here. So the final answer for this, that the vertical asymptote x equal 3 for this function.